It's been a while since I've released the last learning video. So I was learning things here and there, and I'm still learning. So I haven't given up on this journey yet. And what I'm planning to do is do this last video and start a new project on focusing on computer vision. So I'm going to find some sort of like a very trivia project and do a Django application and push whatever I achieve on that trivia project into that application and just make it available somewhere on the web. So I'm just going to continue in that journey, and I'll just start to create new series of videos as I do that. So yeah, and let's just get started. So now here on optimizing model parameters chapter, we've pretty much covered most of these code and we've talked through. And I think I'm going to start here. So we have learning rate, batch size, and epochs, right? So epochs are basically, so when you're learning or training, you will iterate over the data set from, let's say, data 1 to data 100. But then when you're training, you also want to keep iterating over this entire data set as much as you want as well. So that's the epochs, right? So 5 times we're going to go over that same data set again and again. So this is more like a high level iteration on the data set rather than going through each data set. So that's epochs. And batch size is the number of data sample that we pull from the entire data. So we do it in a batch. And then the learning rate, which we'll go into in depth, which is part of today's learning that I'm sharing here or trying to share. Um, and then we have the loss function. So cross entropy loss. On a previous video, I've covered that. And we have an optimizer. So this is, let's just read what it says here. Optimization is the process of adjusting model parameters to reduce the model error in each training steps. Optimization algorithm defines how this process is performed with the gradient descent. So we will cover that, and that's going to be main focus today. Let's just go down to the code here, and we will talk about what's happening over here. Um, so basically, we are calling model.train here, and we are starting to create, pass in the input to the model, and then we have a loss. So once we have a loss, so we know how wrong the output is, then we're doing backward pass on it. So what backward pass means is we are calculating something called gradients, or they also called grads in PyTorch. So the gradients are basically, they tell you, they give you an insight into like how much when you change the weight, um, how much does that influence the loss function. So if you go on, let's say we have weight number 0.05, so the gradient will tell you if you go higher, how the loss function will react, and if you go lower, and how will also that react. So it basically gives you this insight into the loss function. So then that's the idea where we can play around with this and change these values enough so that we reduce the loss at the end. And that's where this calculation of gradient happens in backward pass. And the way that is achieved is through derivatives. And I'm still struggling to understand derivatives on its entirety. And that's because you need really good grasp of algebra. And also, I think there was one more thing. But I think the fundamental thing is you need a really good grasp of algebra, especially linear algebra. So I'm still going to go down on that rabbit hole and try to learn everything. Um, and hopefully one day I'll make a video about it. But yeah, so I'm sort of taking it for, yeah, I'm sort of kind of like leaving it there for now because I don't want to get stuck on that particular thing. But we do understand that the gradients, So, for example, if we go here, right, this is, I found this link through Andre Kapathi's lecture uh, in, it's one of the university lectures. So it's not the usual Andre Kapathi channel. So I'll just quickly show you. If you just type Andre Kapathi, it's the second channel that comes up with a weird, so yeah, like a, not a weird, like a eye. So I guess sort of like a computer vision symbol there. Um, so yeah, I found on one of the lectures. Anyway, so you can also take a look at that if you're interested. So here, if we look at this really cool like way to play with the model. So here it says parameters W and B are shown below. So weights and biases. The value in the bold is the gradient computed with the backprop. Sorry, the value is in bold and its gradient computed with backprop. So back propagation, I was saying backward pass, is in red and italic below. So this is the gradient, this is the weight, and we have a loss here, right? So we've calculated gradient and now it's telling us because this gradient is negative 0.38, if we actually change this value towards positive, because you need to go opposite direction of the gradient. So if you we change this to positive, the loss will drop, right? So we'll have a reduced loss, which is good because that means your prediction is more accurate. So if we increase that, drop to 5.78, right? Let's try a different number. So here we have a negative 0.11. So let's change this number to maybe let's try a positive. So we have positive 0.50. Let's drop this down to negative. So basically we are going on a negative direction for this weight. And then we have 5.70. And if we keep going down, 5.63. Now, if you just keep going down on one particular node here, then eventually your loss may start to increase because you're only playing with this number. But that's the idea. That's what gradient tells us, right? So if you then, in that case, if you think about neural network, it's really a informed brute force. It's a algorithm or we can even can we call it a system? I don't know. So anyway, it's an algorithm that lets you brute force your way into solution. But when you say brute force, it's really brute force does not get you, it can only get you so far, right? So you are doing an informed brute force, and it's so then you yeah. So I'm getting stuck here. So you're basically first time you're iterating over, you're going on a forward pass. Your weights and biases are very random, and then you do a back propagation. So you calculate using derivatives, and you get all the gradients that tell you how mm, the loss function will react to the change on these weights and biases. So now you do a second forward pass. Now your second forward pass, the weights and biases output is not going to be random because we are going to use these gradients and apply that on a weight, right? And the way we do that, now we go back to this page here, and we have this learning rate, which we saw here. Um, and the way we do that is just because this gradient is, let's say, negative 0.57, we're not going to just jump on a positive direction immediately towards this, right? So what we're going to do is, let's say learning rate is 0.001. We're going to multiply that with our gradient 0.057, and then we're going to use this to take a step towards that direction that gradient tells us to go. So, and if we do that, so this is why overfitting can happen if you try to go towards that direction very fast. And if you go very slow, then you're training for too long. or you're basically training, and you're slowing down. So which is why you use a lot of optimizer and things like that to get to the accurate model faster. So, but that's the core of it. I have understood this, and I'm pretty happy with where I am at with it. I hope what I just explained makes sense. If it doesn't, please leave a comment below. I'm more than happy to go through this again, or even if you challenge my learning, I'll try to go dig deeper and come back on that. So yeah, that's basically what's happening here. So we do backward pass or back propagation. We now have gradients on our model, and then we do optimizer dot step. So this is a second forward pass here, right? And then when we do a second forward pass, so now we've gone all the way down to loss again, and our loss has reduced, right? So here, so basically what we've done there is when I go on a negative direction, so 5.63, this is one step. So we did a backward path, and when I go down, you can see immediately there's a new gradient calculated, right? So, and because we've gone forward on our model, forward pass, now all those gradients previously calculated are no longer valid, so we reset them to zero. And Andre Kapati mentions on one of his videos, like these are one of the um, easy thing to overlook when you're training a model or when you're building your model. So yeah, you always need to reset your gradients for each forward pass, because once you do the forward pass, they need to be updated because now you have new value on your weights and biases. And then basically after that, we're just calculating loss and showing loss here. And then we have test loop, which just tests how accurate our model is using the model. And then we have a label. So we just pass in the data and say, hey, did it predict what it's supposed to predict? And then we calculate the accuracy of it. Um, that's mainly what I wanted to cover on this video. The rest of it is pretty easy to follow through, I think, in my opinion. So yeah, I'm not like, I hope that was sort of what I just covered there made sense. And likewise, like I said before, just please comment or ask questions if you think I can clarify myself, or I can do more research on any of these topics. So thank you for watching, and I'm super excited to start the new learning on just using something basic for computer vision. It could be just predicting like what's in the image, like finding cat, dog, or mouse on an image or something like that. And yeah, I'll see how I go with that. And thank you for watching this video.